Alrighty, let's go ahead and finish up 8.1 notes. So we're going to start out with area of an oblique triangle. So we actually have three different equations for this. We have 1/2 BC sine A, 1/2 AB sine C, or 1/2 AC sine B. They're all going to give you the same thing. It's just you have to use what you have. Basically, you need two sides and the included angle. So if you have SAS, you can find the area of a triangle. This little note, when any of the angles are equal to 90 degrees, the formula gives the area of a right triangle. Obviously, because if the angle is equal to 90 degrees, then it is a right triangle. Excuse me. This is probably the easiest thing of the section and the most useful thing, because now we can find the area of triangles without having to, first of all, know the height, and second of all, know that they're right angles. So it's useful, it's pretty easy. All you need is a calculator and to know two sides and an angle. Excuse me. So find the area of a triangular lot having two side lengths of 90 meters and 52 meters and an included angle of 102 degrees. So in this case, they tell you two sides and the included angle. You don't really even need to sketch a picture. You don't need to know which one's A, which one's B, and which one's C. You know the two sides are 90 and 52. And then you know the angle is 102 degrees. Then you can just enter that on your calculator and you get 2,289. And since this is area, it's in square meters. I hope you pause me and try this one out for yourself. Find the area of a triangular lot having two sides of lengths 24 inches and 18 inches. So area, our two side lengths are 24 and 18. And then our sine of our angle. So we just enter it in on our calculator and we get about 213 square inches. Since it's area, it's square inches. So again, I think this is really useful. In 8.2, we'll get another area formula, so another really useful thing. But again, oops, I just clicked something I didn't mean to. Okay, then we have a couple applications problems. Excuse me. So, the course for a boat race starts at a point A and proceeds in the direction south 52 degrees west to point B. There's a picture on page 567, but I'm going to draw it here. So we start at point A. So let's just say that this is point A. And we go south 52 degrees west. So we're going southwest. So that's about like this way, let's just say, to B. Okay. And then we go, then in the direction southeast, 40 degrees to a point C. So then we go to point C. But remember, we're going southeast 40 degrees. So that's, remember bearings from chapter 6 with north, south, east, west. Bearings were a little bit weird. Bearings were a little weird, okay? And then we go back to A. Point C lies 8 kilometers directly south of point A. So we're going from A to B, from B to C, and then from C back to A. This angle right here was 52 degrees because it said that the bearing from A to B was 52 degrees. Now, it wants to know the total distance of the race in this course. So if this is side C, this is side A. To know the total distance, we would need to find C and find side A and then add up all of the sides because that's the total side that we are driving the boat or paddling the boat. It didn't really say what we were doing to the boat. Okay? To do that, we're going to have to use law of sines. And to find the sides, we need to know the angles. Okay, that's quite obvious. So to do that, we need to realize, and this might not have been obvious, this line right here, this north-south line, is parallel to this north-south line. Which means that this 40-degree angle is congruent to this angle right here. So angle C is also 40 degrees. And since we know angle C is 40 degrees, angle B has to be 180 minus 52, 52 plus 40 degrees, which would give us 88 degrees. So angle B is 88 degrees. So now that we have all of our angles, it's going to be pretty easy for us to find angle A and angle C. So I'm going to use angle B and side B as the what we know. So 8 over sine 88 degrees is equal to, let's just find C first, C over sine 40 degrees. So C is equal to sine 40 degrees times 8 over sine 88 degrees. So this would give you about, if we rounded 2 decimal places, and you do this on your calculator, 5.15 degrees. Again, if you're struggling at doing this on your calculator, I do the fraction first, hit enter, and then multiply by this. So then I'm going to use this again and set that equal to my A fraction. Let's change colors just because. So A over sine 52 degrees is equal to 8 over sine 88 degrees. So A is equal to sine 52 degrees times 8 over sine 88 degrees. So A is about, if we rounded 2 decimal places, 6.31. And this is in kilometers. I should have labeled that, but I'm bad. Okay, so it wanted total distance, so we would add 5.15, 6.31, and 8, and we would get that the total distance is 19.46 kilometers. which is the total distance of the race. There's also a picture for the try, but I encourage you to try to draw it yourself just because it's always good to just, try to draw it, a diagram. On a small lake, you swim from point A to point B at a bearing of northeast. So you're going northeast. So we're starting kind of down this time, and we're going northeast. To B. Then to point C at a bearing of northwest. So then we go like up this way. You know what? That was really bad. A, C, there we go. Kinda. We're just gonna pretend that that is perfect. Our bearing here was 28 degrees. And then our bearing here was 58 degrees. Never drawn to scale, remember, because I am awful at drawing. Remember, these two north-south lines are congruent, so this is also 58 degrees. That means we can easily find, it also gives us that side B is 800 meters. So we can easily find that angle B is 94 degrees. So, using the same strategy we used up above, we can say that C over sine of 58 degrees is equal to 800 over sine of 94 degrees. So C is equal to sine of 58 degrees times 800 over sine of 94 degrees. So C is about 680.1. We would do the same for A. So A over sine of 28 degrees equals 800 over sine of 94 degrees. Dang it. Where did it go? So A is equal to sine of 94 degrees times 800 over, sine of 28, I'm sorry. Over the sine of 94 degrees. So A is 376.5 meters. Adding up B, A, and C, you get the total. which is 1,856.6 meters. So your homework for this week is this one right here. And then Google Meeting